We're going to look at the lower part of the section as currently exposed here at Campo Pit. We're going to see the Redbank into the Tinton formation, which is unusually well exposed today. So come on and follow me up. The Redbank are the red sands below, reddish brown, and the Tinton is the gray sands above. Going up that cliff then to the indurated zone at the top is the top of the Tinton. We're going to come up and take a close look at some of the Redbank. The Redbank is a burrowed shore face sand, not too dissimilar from the Tinton, but as you come up you can see it has burrows in it, but the laminations are generally planar. So that's planar laminations are telling us that we're getting into the upper shore face, getting near the beach and the foreshore. This very clean white quartz sand that has about 1% opaque heavy minerals in it. This is the beach. This is the area just offshore, the so-called swash zone. Very seldom preserved in the stratigraphic record, but this is a beautiful example. It's overlain by the Tinton, and even from there you can see that there's an irregular contact, okay, coming over here. This irregular contact is a minor unconformity as a surface of erosion or non-deposition. And above it is the Tinton, which is a slightly clayier sand, also deposited in a shore face environment but in slightly deeper water. You can see faint laminations in here that I'm tracing out. These are trough crossbeds in the Tinton. This is telling us that we are in the upper shore face. So our environments of deposition have shifted. Upper shore face, foreshore, and then back to upper shore face. This isn't a tremendous change in environments, but at this shift from shallower to deeper environments is probably associated with a minor sea level fall and then rise. And then we have the Tinton. This unconformity is probably about 500,000 years older than the Cretaceous Paleogene boundary. But again, today the Tinton is remarkably well exposed, so we can actually see some of the crossbedding in it that is often very difficult to see. And we can see this contact very well exposed. This area just sloughed off, slumped probably during the last storm, exposing this. And so every time we come to these outcrops in the coastal plain, it's often very different each time. And then you can see the cliff going up to the indurated zone, and then the green Hornerstown above, and that's what we walked up before at the other outcrop.
Go ahead.
Okay, thanks to the field team, particularly JN, for pointing this out. This is a very nice contact and actually tends to prove the hypothesis that the boundary between the Redbank, which you can see is the reddish iron stained sands, and the Tinton, which are these white sands, is in fact an nonconformity. You can see that at this particular part of the outcrop, the boundary between the two is an indurated zone. And that meant that there was some kind of diagenetic potential for this induration to form. Maybe it was a little bit of a oxidized layer or whatever, but it has been preserved here. And so this is equivalent, even though it's heavily stained, this is still the very, very clean, beachy sand, white sands that we saw at the other outcrop. And then the indurated zone, it's rock hard, okay, iron cemented, and then overlain by the Tinton. Now you can see the Tinton here at the base has little bits of clay in it. It is not hugely different than the clean, formerly white now, stained sands. So there's not a huge environmental change. Again, the change would be from most likely something that we would call foreshore, the beach, and something we would call offshore. So there was not a huge change in facies. So if sea level lowered, it lowered by 10, 20 meter range and then flooded back in. In fact, this is a flooding surface, as Kristen pointed out. It is a flooding surface because this is deeper water than what's below, but usually that implies that we missed something during the low stand of sea level, lowering of sea level. So most of our unconformities in the coastal plain actually show deepening across the erosional surface. But this is the surface that we traced over just on the other side there, in the other outcrop, and it's irregular over there, and that irregular surface has been cemented here and preserves a record of the unconformity. And again, now we look up, you can see approximately 3 meters or so, 10 feet of Tinton formation preserved here. And as a footnote for geologists, young geologists, on a map, 10 feet is usually about the minimum amount you would map. And Jim Owens, who mapped here back in the day on the New Jersey map, the so-called central sheet, you can go look it up, he mapped the Tinton here, and kudos to him, identified this unit as distinct lithologic unit. But very simply, it's the reddish sands and the white sands. Redbank, reddish, white Tinton.